Hey guys, so today we have a session on GCP. Will be taken by Milan Menezes. He's an alumni of our college, and he was in CSC. And so, right out of college, he took a job at Shell. And recently, this year in August, he joined Google as a technical solution expert in the GCP department. So we thought, who better than someone at GCP to tell us about Google Cloud Platform? So yeah, that is about him. I'll give the stage to Milan now. Milan, you can start the event.
Yeah. Hey everyone. Let me just turn on my video. Yeah. So I hope you're all safe and doing well during these troubling times. And welcome to this session. And also a big, kudos to the organizing team for doing this and having me over. So let's begin. So just a short info about myself. I am working as a cloud technical solutions engineer at Google. I joined about 3 months ago, and I work mostly with the cloud platform products at Google. And we will be discussing a few of those products today. So let's talk about the agenda. So before beginning with actually doing things, we'll have to discuss some parts of theory about what things are and understand how things work. So firstly, we will talk about cloud itself and the service models and virtualization and containerization, and then Dockers for containerization. So we would be discussing these three things through slides, and then after this, we would move on to the hands-on part. So to begin with, we will deploy an application to the App Engine, a simple application, and then we would look around how to use the Cloud Run, and we'll also look at how we can have CI/CD workflows using Cloud Build. So this is what is planned for today. And I would also like to tell you guys about what we would not be talking about today. So we will not be talking about the core infrastructure of Google, Google Cloud. We will not be talking about the pricing things at Google Cloud. We'll also not be talking about in depth in terms of virtualization, containerization, or any of these topics. So this is what is planned. So let's start with what is cloud itself. So to put it, in simple words, when you say cloud, it is the delivery of services like compute or let's say the storage or networking or a software or a platform to customers on demand. So when a customer requires something, we should be able to deliver these things. So in terms of infrastructure, it might be the storage or compute power or networking. In terms of software, it might be any SaaS product, or if it's a platform, we could give them APIs to consume some resources. So this is what cloud is. This is not much about cloud, but there are three models. So to start with, you have the infrastructure as a service. We have the platform as a service and software as a service. So to talk about traditional systems, all of these things would be managed by the customer itself. So the customer would purchase huge machines. They would have hosted that in their own offices, and they would run their applications on those. The problem with that is that when you have, let's say, a machine of let's say 16 cores and about 64 gigs of RAM, and you're running all of your applications there, you cannot provide the same level of abstraction as these cloud services provide. So if I have to run multiple applications, I will have to run them on a single uh, let's say operating system, and all of these resources will be shared. You cannot isolate systems, and you cannot package them as efficiently as the modern day cloud does. So that's what brought about these services. We will talk about virtualization later on. So to talk about infrastructure itself, um, you can see the green boxes here. So the green ones are managed by your cloud providers, and your black boxes are managed by the customers. So when we talk about infrastructure as a service, so I'm sorry. So your networking, storage, servers, and virtualization is taken care by the cloud provider, and the rest of the things where you have your operating system, your middlewares, or your runtimes, or libraries, your data itself, and your applications. These things will be managed by the customer. So if I were to go and ask a cloud provider that I need, let's say, a machine of so many cores, probably also mention what type of CPU I would want, and state, let's say, how much of RAM I would need, how much of storage I would need, what type of storage I would need, and what type of networking I would need. Do I need like standard networking, or do I need premium networking to have faster speeds and latency? So these things come under infrastructure as a service. So I could request for these services, and these would be provided to me almost instantly. And when we move towards platform as a service, there are multiple instances of customers not wanting to manage most of these things by themselves. So when you look at this part here, till the runtime, all of these things will be managed by the cloud provider itself. So the customer only has to take care of their application and their data. So they would not need to configure what type of CPU or how much CPU they would want, or how much RAM they would need, or how much storage they would need. It's all taken care of by the cloud provider itself, and all of these things are scaled. So whenever the customer needs more, it's scaled horizontally or vertically. When it's less, it's scaled down. So this is what a platform as a service is. When we come down to the software as a service, all of these blocks are taken care of by the customer itself. I'm sorry, the cloud provider itself. So if you use, let's say, Gmail or Google Docs, or any of these applications, all of these things run on the cloud, but you do not specify how they are running, and where they're running, or what type of CPUs are running at, and what RAM they would use, or what type of storage they would use, and how they're organized. So all of these things are taken care of by the provider itself, and all you have to do is take a subscription to it and use the software. So this is the software as a service model. Today we would mostly be talking about platform as a service products. So let us begin. So to begin with, we will have to discuss something on the grounds of virtualization and containerization. So what exactly is a virtual machine? So initially, when I spoke about a big machine, right, you have a lot of, you have a couple of CPUs, and you have lots of CPU cores. You have, a bunch of, RAM sticks there. You have, let's say, hypothetically, we have 16 cores of CPU and about 64 GB of RAM. So what a virtual machine does, or an hypervisor does, is it takes that physical machine, and it gives you a couple of a set of virtual machines, virtual environments itself. So these virtual environments are isolated from one another, and they run at the same time. The advantages of doing this is better resource utilization. And let's say if I want to run different operating systems at the same time, I can do that with virtual machines. We have two types of virtual machines, the hypervisors itself. One, we call it as a native or bare metal. The other one is hosted. So what bare metal does is that we have the software called as the hypervisor. Hypervisor is responsible for translating these virtual machines into, or rather translating, let's say, virtualizing your hardware itself and providing them to your virtual machines. So if you have, let's say, the 16 cores, you can divide them into two virtual machines of 8 cores, or you can divide them into 4 virtual machines of 4 cores. So all of that is taken care of by the hypervisor. And for the virtual machine, logically speaking, for the operating system itself that runs on the virtual machine, it would see the hardware as it is. So it will not know that this is an hypervisor or any of that sort. So for the virtual machine, it is something like it's running on the hardware itself. So that's what the hypervisor does. In bare metal, your hypervisor runs directly on the hardware, and you have these guest operating systems, which are virtual machines running on them. And the second type is called as the hosted virtual machines. So you have one operating system running on. Yeah, Prashil, you have something to say? Also, guys, feel free to ask any questions at any point of time. Here, you can always, stop me at any point and ask anything. So you don't have to, have this as one-way communication. So in type 2, you have your host operating system, and on top of this host operating system, you can have the hypervisor, and then you'll have virtual machines on the hypervisor. So to give an example, for the bare metal, you could look at the hypervisors like VMware hypervisors that the VMware provides, and for the hosted type, you could look at VirtualBox from Oracle. So you could try this in your own computers. Let's say if you're running Linux or Windows on your system, you could install VirtualBox and then spin up some virtual machines on them. So this, there are differences. I mean, there are advantages and disadvantages in both of these things. Let's say if you consider the hosted type, for this guest OS to run, you would have your host OS also running at the same time. So your host operating system will also consume resources, and your hypervisor and all of these guest operating systems would consume more resources. So it's heavy on the resource front. But what it provides is it provides even more isolation from the hardware. So if you decide to wipe the whole thing out, you could just uninstall your virtual machines and your hypervisor, and it does not have any effect on your host operating system. So just to give an example, if in India, most of the people are more comfortable with one operating system, and they don't usually change those. So you could say it might be Windows. So if they're running Windows, they could just install one hypervisor on it and then run virtual machines, and it does not affect Windows. You can just wipe that out. Coming back to the bare metal hypervisor, in terms of resources, this is more efficient because you don't have a host operating system. You have your guest operating systems running directly on the hypervisor, which runs on the hardware. So in this case, you will have to install the hypervisor on your hardware itself. It does not run on Windows or Linux or any other host operating system. So to change things, to have to wipe, let's say, the hypervisor, you'll have to wipe the whole thing and install things from the beginning. So that's the difference in this one. So this is another image which shows you how memory is virtualized. Let's say you have your memory here, and the brown blocks are your physical memory, your memory in your hardware. Let's say 64 gigabytes of memory, and you have two virtual machines running here, and the gray boxes are the memory blocks that are virtualized and given to these virtual machines. You could say 32 gigs on the first virtual machine and 32 gigs on the second virtual machine. And you could also see that these things are isolated from each other. They're not, just to speak of this, let's say your virtual machine 1 cannot access the memory space of virtual machine 2. It would get a segmentation fault. So it's the same thing with the processes as well. Even the process memory is isolated from each other, and you can see the isolation here from the blue box to the gray box. So that is your process isolation, and then from gray to your brown boxes, that is your virtual machine memory isolation. Okay, this slide we talk about containers. So why we have containers, why were containers introduced, and what is the advantages of containers, the differences of containers from virtual machines. So speaking of the dedicated server, as I spoke before, you will have your hardware, your kernel. Kernel is nothing but the core part of your operating system, which takes care of handling your IOs and managing your devices and providing APIs or system calls to your operating system. So in this traditional dedicated server model, you have your hardware, your kernel dependencies, and your application code running all together. And to plan this and to deploy this, you would need a lot of time. So it would consume about a month's time to plan all these things, get these resources, and to put this together. Coming to the virtual machine space, since you have your hypervisor and your hardware ready, this the dotted box is your virtual machine. You have your kernel, your dependencies, and your application code together. So I could say there's one virtual machine which runs Windows and a couple of dependencies on that, and then your application might be something to do with Python, Flask application, or it might be a Node.js Express application or a React application running on it. So you have isolation from the kernel level. So you have a different kernel, a separate kernel running on one virtual machine. You have your dependencies and your application code running. The problem here is that you will need a different kernel for each of the virtual machines, and to build this and to ship this, it's a pain. So if I have to build an application and I have to ship that out, doing it in this way, my application would depend on the kernel as well. So I will have to design it in such a way that it runs on the kernel. So let's say if I'm building one application, I'll have to build a different, I'll have to have different executables for Linux. I'll have to have different ones for Windows, different ones for Mac, and so on. So that is one of the issues that you have with building in terms of virtual machines. So that led to something called as containerization. So this is a container. The dotted boxes here is a container. So you have your hardware and your kernel and your container runtime. In our case, that's a Docker engine, common to everything. And you have different containers here. You can have like multiple containers, which only consists of your application code and your dependencies. So the advantage here is that you don't have different kernels inside each of your containers. So you have just one kernel running, and you have different containers that run upon this kernel and your container runtime. So when you have to build something in this case, you just have to worry about your dependencies and your application code, and you can ship this out to any of the kernel systems. So if you build one Docker image, you can ship this out to any of the underlying operating systems. The same thing can be run by all of the operating systems. So that is the advantage. And to scale these things, it's very easy to scale containers. So once you build an image and you have containers, to create a container and to scale this out, it's very easy. You can do it in seconds. So that is the other advantage of having the container itself. So now let's talk about Docker. Docker is one of the type of containerizing systems out there. So yeah, this slide also gives you the differences between the virtual machines and your container. In the virtual machine, you have your core infrastructure, you have an hypervisor running, and you have these virtual machines. So red, orange, and blue or greenish color. So these things are your your virtual machines. You have your guest operating system, your binaries and libraries, and your application running. And in your container, you have your infrastructure, you have the operating system, or you would say the host operating system. You have your container engine, which is the Docker, and you have your containers running here. Application 1, 2, and 3 are 3 containers running on top of this. Advantages of Docker. Let's say in terms of memory usage, if it's a virtual machine, you will have to block a certain part of your memory for a particular virtual machine. So in this case, we have 3 virtual machines, and we have blocked 6 GB, 4 GB, and another 6 GB for your virtual machines. And when, let's say, the first virtual machine is using only 4 GB, your other 2 gigabytes of memory is wasted, and it cannot be used for any other purposes. Same thing when you consider Docker, of your total 16 GB, you've allocated 4 GB, this is 35, but yeah, you've allocated another 10 GB here. If your application is only using, let's say in the third case, 2 GB here. The other 8 GB might be used by other containers. So it's not blocked for one container, and this increases your efficiency in terms of system resource utilization. In your first case, in terms of virtual machines, we wasted 7 GB of memory, which could have been used for some other purposes, and that's one of the advantages of Docker. Docker components. So we have a couple of components for Docker. The first thing is your Docker client, and then you have your Docker daemon. Docker daemon is your Docker engine running on your host, and we have something called as Docker images. We have Docker registries. We have Docker containers. So how does Docker work? Docker client is, let's say, the tool that you would use to interact with the Docker engine. It might be, let's say, the Docker command that you run on your terminal, or and your Docker, engine, or your Docker daemon is a daemon that runs on your host computer. So daemons are nothing but applications that run on the background. So your host is your computer itself. Let's say you have a laptop, you've installed Docker engine on that becomes your Docker host. And your Docker daemon, is it's something that creates your containers and manages your images. And your Docker client, which is your command line Docker command, that interacts with your Docker daemon to spin up containers. So some of the commands that you would normally use would be Docker pull, Docker run, and so on. So let's talk about the Docker architecture itself. You have your client and your Docker host. Both of these things run on your laptop itself, your local computer. So your Docker daemon interacts with your registry. So let's say you do something called as Docker build. Docker build is something where you build an image. An image is something if you've used Git, it's synonymous to a Git commit. So you have a layer which is an image, and you use that layer to spin up your containers. So you could also look at it like a program and a process. You have a program written in a language, so when you execute that program, it becomes a process, right? So similarly, you have an image. So when you run that image, it becomes a container. So this is the system to do that. So when you run Docker build will basically build an image from a Docker file. We will also talk about what a Docker file is. But when you run Docker build, your Docker daemon will take your Docker file. It will execute the steps that you mentioned in your Docker file, and it will build an image. And that image is stored locally in your system. Then when you do something called as Docker pull, your Docker daemon will reach out to a registry and pull this image. So what a Docker registry is, it's synonymous to your Docker hub. So you have Git, which is a system, and you have GitHub, which is a service provider. So it's a remote repository for having your repos in a common repository. It's similar to that. In Docker, you have Docker Hub, and you have other container registries, and even in Google Cloud and other places. So you could look at this as GitHub itself, something as GitHub. It's in Docker terms, it's the Docker Hub. So you remotely store your Docker images on the registry, and you can pull them. And if you have to, let's say, distribute your application, your package, so you create an image out of it, you push it to your Docker registry, which is Docker Hub, and people can pull that. So it does not matter, let's say, which operating system they're using, they'd still be able to use it. So this image is not just your code, it includes your dependencies, it includes your entire environment. When you so that's what Docker pull is. When you run Docker pull, your Docker daemon will check if you already have that image in your system. If you do not have this image in your system, it will search Docker Hub for this image, and it will pull that image and store it in your local system. And then the third command is your Docker run. Docker run, as I said, it will take your image, and it will run a process. It will spin up a container for this image. It's an executable of your image. So let's say you're running Docker run, and you're spinning up a Ubuntu container. So you see that you already have an Ubuntu image in your system. It'll just spin up a container from this. So this is the basic architecture of Docker. Yeah, let's talk about Docker files. So one other thing that you should note is that in Docker, like everything is in terms of layers. So if you start with one layer and you build upon it. So if you start from, let's say, Ubuntu or some other image, and you do something, that would be another layer on top of it. And all of your layers are read only. Only your topmost layer is read and write. So if you let's say start with one image, you do something, and you uninstall a couple of things from your source image, the size of your container will not reduce, because as I said, it's layered. So it will just be another layer on top of the previous layer. So this is the Docker file. You build Docker images out of Docker files, or you take up another image, you spin up a container from that image, you make your changes, and you commit that as another image. So this is a simple Docker file. So if you see the left side, you have the from command. From basically says which is your source image. So we're starting from Ubuntu source image, and then you can skip the maintainer part. Maintainer is just kind of like a meta command which states who's maintaining this. And you're running apt-get update. You're also running apt-get install nginx. So if you look at this from a Docker standpoint, you have your Docker engine. Your Docker engine is not running your like Ubuntu kernel. It is running a standard Linux kernel. And when I say your binaries and libraries, when you start with your Ubuntu, so only the binaries of Ubuntu are taken into consideration here. You don't have the kernel itself being packaged here. So because it's Ubuntu, you're able to use apt-get here. If it was something more on, let's say, Arch Linux or Fedora, you would have to use different package managers. So this basically creates one image, and this image is with the source of Ubuntu, and you've just installed nginx on your Ubuntu image, and this is another image now. So if people have to write applications on this, they can take this as the source image, and they can write or they can develop on things. I see some chats here. Okay, it's just general information. So on the right side, this is another simple Docker image. I'm sorry, Docker file to build an image. So we're starting with Python. Python is another, you can say, an image that you can pull from Docker Hub, and you're setting a working directory on your container. You are copying a file called requirements.txt from your local system, file system, to your container. Then you're running pip install inside your container, and then you're copying everything else in your working directory on your system to your Docker image. And lastly, you're running a command which is Python and a Python file name. It might be a daemon or a script. So one thing to note here is that, as I've already told you, your Docker container environment is isolated from other containers and your host system. Copy gives you an option to copy your data from your local system to your container. There's also the option of mounting a folder from your host system as a folder within your container if you want to have persistent storage. So to give you an example, if let's say I have a container, I start a container, I do something within the container, and I kill that container. All of these things can be done within seconds. But when you kill that container, the data that you have within the container is also lost. To have persistence there, that's where you actually have more volumes that you mount between these containers. Looking at this Docker file, you might have a doubt that I'm copying requirements.txt first, running pip, and then again copying the rest of my files. So why might I not copy all of my files in one go and then run pip install? You can do that. There's no issue with doing that. But doing it in this way gives you, it has a couple of advantages. So you have something called as caching here, and running just this part first would cache this part first. So it's a general rule that we follow, where you have, let's say, not so changing stuff in the beginning and frequently changing stuff at the bottom, so that the top part of your file can be cached. All right. So we will do all of these things hands-on. We will, work on all of these things. I will show most of these things to you. So if you, I think there was an email sent out to all of you, I think yesterday, where if you have set up your Google Cloud accounts and installed Docker, you could do these things with me. If you don't have them ready, you can. All right. Can you explain how work directory works? Sure. So all the commands that you write here, right? All of these things run inside your container. So when you build an image, all of these things would run inside your container. What work directory does is that inside your container, it sets this whatever thing that you put after working directory, it sets that as your working directory. So everything that you run after your work directory part, right, after this, would run within that folder. The structure actually depends on what image you're running from. So if you have Ubuntu, you would have the basic Linux file system of Ubuntu within your container. So you could have, let's say, you have your home directory slash is your root, and you have your etc directory, you have your user directory. No, when you write something here, I think I'll also have to speak this out. So Shrish has a question. He's asking me, does the usr/source/app directory already exist within the container? It might not exist, but writing this here will create that directory and move inside that directory. So it will cd into that directory. Yeah, I hope that answers your question. You could define, you could put in, let's say, /home/ some random name / another directory, and it will move into it. Is it possible to run a container within a container? Yeah, I think you can, but it won't be efficient, because you'll have to run an hypervisor within your container. I'm sorry, your container. Let's say your containerizing software within one container, then run it again within that container. Nobody does that because it's not efficient. This container, would act mostly like a virtual machine itself in that case. Yes, it can be anything. So if you want to try these things out, you could spin up a virtual machine, run a containerizing software. It can be Docker. You can just install Docker and then have containers there. So that's the general way of doing things. So let's start deploying. So yeah. So let's do it this way. I will do it in my system here. People, if you already have set things up, if you have your Google Cloud account set up, and for this case, we don't need Docker. So if you have your Google account set up, you can do these things with me when I do it. If not, you can follow up with me. You can just watch the demonstration, and you can do it later whenever you set up your system. So can someone confirm that they're able to see other tabs in my screen?
Yeah, Milan, we can.
Yeah.
Thank you.
So I will start with access forbidden. Good. I think I open up a different project. Let's start with the new project itself, so that it's easier for folks to also replicate these things. I will name this DSC NIE Cloud. You can name it whatever you want. Once you name it, it's permanent. You won't be able to change it.
Milan, sorry to interrupt, but could you zoom in a bit, because it's kind of hard to see?
Yeah, sure.
Thank you.
So this is your project ID, and it's permanent. Once you do it, you will not be able to change it. So you can have like multiple projects, right? So you can deploy resources to any of these projects, and you'll need to specify which project you would be deploying when you run this on your command line. And let me go ahead and create this. So you can see this the bell icon there. It will just give you your notifications. So whenever things are done, I will select the newly created project. Yeah. So at this stage, let me just give you a brief introduction to what the App Engine is. So Google App Engine is a platform as a service product that Google Cloud provides. So what it basically does is that it takes your code, it itself containerizes your code, and it'll run it on Google's container orchestration infrastructure. So you might have heard of Kubernetes. We have something similar that we run here. So your application, your code is built into a container. It's built into an image, and it runs as a container in Google's infrastructure. So the advantages of App Engine is that you don't have to specify which CPU you want, how much resources you want. It scales up automatically. And in terms of your requests also, right? It manages your requests. So if all the requests that come into App Engine, it's queued, and then there's something called as your app server. There are like multiple app servers running in different zones, and the one that is free, serves your request. So let's say you're getting a lot of requests, and your container is not able to respond back. Your App Engine will scale it up. So your App Engine will spin up a new container instance, and it'll direct the request to that container. So that is what the App Engine does. Couple of advantages of App Engine. We have two types in App Engine itself. You have the standard and you have your flexible environment. Standard is what all I spoke to you about till now. Flexible is something where if you're not comfortable with the standard environment, if you want your very own environments, very own, let's say if you want a language that is not supported by the standard environment, or let's say your builds would take more time, consume more time that is not allowed by standard, you choose your flexible environment. The main difference here is that your standard runs within the Google Cloud's infrastructure as a container, and it can scale down to 0. So when you don't have any traffic coming in, to save your cost, it can scale down to 0. There won't be any containers running, and only when traffic comes in, it'll spin up a container within seconds, with a fraction of a second, to be accurate. So this is the advantage of standard, but there are limitations in standard. You only have a couple of environments that the standard environment supports, and even in Python, you could say, let's say in Python 2 or Python 3, there are only a couple of versions that standard supports, and also you have a couple of other limitations which are in terms of time. Yeah. What Flex does is that Flex will spin up a new virtual machine in your project and run this as a container within that virtual machine. So it'll be like a virtual machine with a single container that's spun up. So that is what Flex does. But Flex gives you a lot of flexibility. You can run whatever language you want. You could choose the environments provided by Google, or you could spin up your own Docker container and have that as an environment. So that's what the App Engine is. So you could search. Let me zoom in a little bit. So under compute, you have the App Engine. You can click on the App Engine. One thing to note here is that you will initially have to choose a region for App Engine, and this region becomes permanent for your project. So for other resources, you can always choose whatever region you want, but for your App Engine, whenever you enable App Engine, you will have to select a region, and that is permanent. You will not be able to change that. If you want to spin up or use other regions, you'll have to create new projects. So I will click on create application, and I will choose the region. Let me select Asia South 1. So Asia South 1 is a Mumbai region, And if you select Asia Southeast one, that would be your Singapore region. And I will say create app. This is like the initial setup. You can select which language and which environment you would want. You can always change this later. This is like not the permanent part of it, and I will just select next. So my app engine setup is done now. So I've enabled app engine. What I would do after this is through my command line. I will take up an application and I will deploy it. So I understand in your day one and day two, you have learned and you worked around Flask application. Let's deploy a Flask application. For simplicity, at this, I just got a notification telling it's been created. So for people who are starting up, right, I don't want to copy code from somewhere and then deploy that. So for this instance, at this point, I will create a new Flask application and I will deploy that. And moving forward, your organizers have given me a repository, so that application I'll be deploying. So let's start. I will let me. Are you able to see my terminal? Can someone confirm if they are able
Milan,
to
it's too small, so you might
Yeah,
need to
I will
zoom in.
increase the size. That's not an
Yeah,
issue.
we can see the terminal though. We
Yeah.
can see it.
So let me just create a directory. So I will use this directory for everything that I would do today. So let's say, let me create another directory within it for this initial application. I will call it, let's say, Flask first app. I assume that you've already, you already know how to create a Flask application. In standard structure, you would have a Python file that would serve your request, and your files, you would organize it into your folders. Your templates would be within your templates folder, and all your static files would be inside the static folder. So I can do all of those things here, but for this case, let me just have the Python file. So I'll be using Sublime as my editor to do this. Let me increase the size as well. So in App Engine for your Flask application, one of the things that you should note is that your file should be named main.py. So let's have your standard Flask setup. Flask import Flask, and I'll initialize the application. This is just a simple request. It will return hello world. So have this as well. Yeah, this is the simplest of a Flask application. We're just the root part we're returning hello world. Let me save this. Yeah. Any doubts till here? Yeah, assume not. So yeah, for your app engine, one of the things that you will have to provide is a configuration file. It's named as app.yml, and what you have to write within it is quite simple. In very simple terms, you'll have to let the app engine know which runtime you do like to use. So I will just write it as runtime, and let this be Python 3.8. So this would use the Python 3.8 environment, and it'll deploy this into that container. I will save this as app.yml. We just have two files here, app.yml and your main.py. We can go back to our terminal now. Can someone tell me, let's say if I run this main.py file, I will get one error. So what would be that error? I'll assume that this is a clean setup. I just have two files here. I have a Python file, and this is the Python file, and I'm executing this file. I'm just running Python main.py.
If it is a clean setup, then I'd assume that you don't have Flask installed.
Yeah, exactly. So in your development, right, you usually don't install anything globally. You maintain something which is called as a virtual environment. So it's a Python virtual environment. So you install whatever you require within that virtual environment. You use that. You define all of those within a file called as requirements.txt, so that when you ship it to anyone else, it's easier for them to install things as well. So yeah, that's exactly what I'm going to do. Instead of let's say, yeah, let me do it. So there are multiple ways of having a virtual environment. I use something called as pipenv. There are advantages and disadvantages of using pipenv. Pipenv kind of gives you an interface to have a different virtual environments, and it takes care of your dependencies and locking your dependencies and stuff like that. But it creates a file called as your pip file. But this is not allowed in App Engine, so you will have to have your requirements.txt file itself. But I can generate that from this. So let me. This is just to test if this is working locally. I just have pipenv, and this will create a virtual environment for me for Python 3. Yeah. So let me install Flask. Sorry, I missed the install part. Yeah. So I've installed Flask. So let me check if this runs locally, so that there's no issues later on. Yeah, let me quickly check that on my browser as well. Yeah, it's working. Because I was using pipenv, you're not supposed to have the pip file as well in your folder when you deploy it to App Engine. So I just wanted to show this to you so that I can also show you how you can ignore files. So you can create another file called gcloudignore. So it should be named as a .gcloudignore. Yeah. So whatever you write it here, right? It's similar to your git ignore. So whatever you put inside this would be ignored while using your App Engine. So I'll just write it as a pip file. and your dot block. So just to demonstrate this to you, you don't have to do any of these things. So if you're just using your standard Python virtual environment, you will not even have these pip files. Or even if you do use the pipenv, you can just delete these files. So let me just save this. So now I will have to also have as I told you, I'll have to have a requirements.txt file. I will just put this on. So now I have my requirements.txt file. As I mentioned, this is just my setup. You don't have to do any of these things if you're like standardly running Python and using your pip globally as well. So you would just require a requirements.txt file. Let me quickly check that. So this contains a couple of things. So if you might ask me why do I have all of these things? I just need Flask. So when we install Flask, all of these other things will also be installed. So this file is just pointing all of these things out. Let's go back to the terminal. Um, I assume that you have already installed gcloud. You can initialize gcloud by using gcloud init. It will basically create a new configuration for you with default, let's say, project details and which account that you would use to create resources. I already have a couple of configurations, and I'll create a new one. So I will name this DSC. It will also ask which account I would like to use. So if it's a new account for you folks, it'll ask you for authorization. So if you're running it on your local computer, it'll open up your browser and you'll have to authorize gcloud from there. And if you're let's say running all of these things in a remote virtual machine and you're SSHing into it, it will give you a string, a URL that you will have to run on your browser and copy the code. So since my account is already authorized, let's move to the next step. So I will just select which project I would want to use, and then yeah, the project is set up. I mean the configuration is set up. Yeah. So to have this right, to deploy to App Engine, all you need to do is type from your folder where you have your files and your main.py file and your app.yml file. You'll have to run gcloud app deploy. So this will do all of your stuff. It'll upload your files. It'll create your it'll let's say put these files into your Python 3 environment, and it'll spin up a container. Let me just quickly run this. So it'll give me your default set. So it will just to confirm, it'll ask me is this what I want to do. Your target project is right. We have something called as service. So if you want to run multiple applications on your app engine, you'll have to do it through services. So I'm using the default one. If you want to run something else, if you want to deploy another application, you can just have it as a different service. And within a service, you can have multiple versions. So to the default version itself, I can deploy different revisions. So if I change something, I can deploy back to the default service, and it'll still retain my previous one if I want to roll back. Yes. So it uploaded the file, and it'll spin this up. So people doing it with me, are you facing any issues? I hope not. All right. This takes a bit of time. So the first time you do it, it'll take time because it has to create this. All right, we have a question. You the question is that should do I recommend App Engine for hobby projects or is it only for production? So you can use Google Cloud App Engine for your hobbies. So if you sign up for a free tier account, with your account you also get $300 to use. I think for 12 months. But your App Engine is your standard is covered under free tier itself, so you won't be using those $300 either. And since the scales down to zero, it's quite good to understand how scaling works and how you can split your traffic. So I do recommend using the App Engine. Since it's very easy to, let's say, deploy, you don't have to do much here, right? You're not writing a Docker file, you're not spinning up containers, and let's say you're pushing your images and all of that sort. So it's just going into your project folder and running gcloud app deploy, and it's done. So we've got this. The deployment is complete. I'll quickly show you what happens on your App Engine screen in Google Cloud as well. I think it's taking time to reflect. Yeah. So we have one version deployed. I can click on this. Yeah, it shows hello world. So what we did here was we created a service on App Engine and we deployed a version to it. So this is the version. It's serving 100% of traffic. I'll also show you how to split traffic. This was, I mean, the first one was just to show you how to start from fresh, just to have, start from the very beginning of Flask and to deploy that. So I will open up another repository on GitHub that your organizers sent me, and I will deploy that. This is a Flask application. So to have writing rights, let me just fork this. You can see that there's one instance here that's running, and it's served two requests. So when you have more requests coming in, and if this cannot manage that, if it's too busy to respond back, it'll spin up new containers. That happens within a fraction of a second. And yeah, this is the version for the default service. We can have different services as well. So yeah, this is done. Let me clone this. So this is one of the applications that I think Shankar created. So I did look at this. It's a flashcard application. Let me run that locally and show you what it does, and then we will deploy the same on the App Engine. After this, I will show you how we do all these things on the Cloud Run, and also having a CI/CD workflow for all of these things. So I'll just open up the same on Sublime. So we're just importing Flask and model. Model is a file which is already which is also in the same folder, and you're importing JSON. Again, I'll do the same thing since I use pipenv. I'll just initialize a virtual environment for myself. Installing Flask. Let me quickly check if this is working. All right, it is working. So a couple of things that I want to point out with this application. It's built well, but this is not a stateless application. So I would also like to say state the differences here. So the reason why I state that this is not stateless is because the data source that is being used is a local file here. So it's a JSON file that is stored here. I will show you why it's harder to scale such applications later. But yeah, let's say if I have to spin up a couple of containers, you're getting, let's say, thousands of requests, and you have 10 containers with you. If you're using a local file like this, these 10 files will be different. Moreover, these files will also be read-only on your container when you spin it up in your App Engine. So this will work. So you can read from it, but when you write to this file, it will not be consistent with the rest of your containers. So let me deploy this as a second version. And if you don't know, let's say, flags or something for a particular command, you can always just look them up on Google. You can just check G cloud. Let's say we're running app deploy, right? I just search for G cloud app deploy. The first link that you get, if you open it, you'll get the documentation for the same. So here you can see what all other things that you can use. So if I open up my App Engine on my console, you can see the version ID, right? The version has a string. So this is a number that was randomly generated and given to me as the version ID. You can you can specify your own versions while deploying. So that would be used as a name. So let me check if this is still, yeah, it's still as one instance. So let's deploy this. But before we do so, I have to rename this file as main.py and also create a requirements.txt file. Let me do that. I need an app. I need a YML file. This file will just provide the configuration to your App Engine. So at bare minimum, I'll have to tell which runtime we're using. Let me also specify a couple of things here. So you know about the static folder, right? So the static folder that you have, your Flask application will not execute any function for that. It will just serve that as static file. And we also know that Flask is a microserver, so you can't use Flask directly in production. You'll have to run it behind some production server, a reverse proxy. It might be Apache, it might be Nginx, or you can have Kunikon. So you'll have to run it behind one of these things. So we can specify in the configurations of these reverse proxies that if the URL is something like a file ending with a particular extension, statically serve that from this directly. Do not invoke this Flask application. So in terms of reverse proxies, if I'm running this Flask application behind, let's say, Nginx, for each request that comes in, your Nginx server will create a new thread and run this main.py file and serve that request. So that's the reason we try to keep these things as stateless without having local storage. So yeah, I will just quickly copy another configuration to this to just tell you what this is doing. So we have something called as handlers. Handlers is how you define like which endpoint of the URL points to what. So what I'm doing here is I'm specifying that if it's /static, serve the files directly from the static folder. So when I use this configuration and we have a static file being pulled out, or in the URL anything that starts with /static, this your Google front end, right, will not run this Python application at all. So it will just serve those files statically. And you also don't need to run Nginx or any of these things in App Engine, because App Engine itself takes care of all of these things. So the typical way in which how this happens is that you have something called as your Google front end. That's any edge location closest to you. So if you're, let's say, in Mysore or Karnataka, the edge location closest to you would be the Google front end. So that would be the location that would serve you files. So that will interact with your backend, your application server through Google's fiber connections. So the internal connections are very fast to make sure that you have the lowest latency. The location closest to you would respond. We have a question. How would you deploy stateful application apps where local files are needed for some reason? Yeah, it is always recommended to use some kind of a database, or let's say a file location which is not your local location. So let's say if it's a relational database, you could use SQL. If it's not, you could use NoSQL databases out there. We even in Google Cloud, you have some managed services which provide these things to you. If it's something like a file itself, you can store these on places like the Google Cloud Storage. It's an object storage where you can store that and use those files. But if you do want to store files locally in your, let's say, container itself, you will have to run this within a virtual machine. So it will not be easier to scale this up. So you will have to have a volume. You'll have to mount that volume and use that. So that once your container is killed, if you start another container, you can use the same volume. So I mean, your files will be persistent. Your files won't be destroyed. So this I just wanted to demonstrate how what this is doing. You have your static files which is being routed. So here, like it doesn't reach your Flask application at all. If it's a static path, it'll your Google front end itself will pick up the files from that directory and it'll serve those, and it'll cache these as well. So based on the caching that you mentioned, these files will be cached in the edge locations, and you'll not be charged as well, because these things are cached and there's no traffic coming out of your container for these cases. So I've just put in your configuration file, I've renamed the main file. Now the thing that I have to do is generate my requirements.txt file. I will quickly do that. So I have my requirements.txt. So instead of ignoring files, I can actually let me ignore the files itself. So let's deploy this to the same service. Let's not create a different service. We will deploy this thing to. There might be a case where we might get an error. So let me create the static folder as well, because I've mentioned that I will be using a static folder. So yeah. So, yeah. So what I'm doing now is I'm just deploying this dcloud app deploy. Let me give another flag. I'll give a name for the version. I'll write it as version, let's say 2. Let me cover another thing here as well. So let's say I'm not confident that this is the deployment that has to be in production, that this has to be served. So I can have something like an incremental rollout. So I will just write this as no promote. So you can find all of these flags when you search for the documentation here. So what this does is that it will deploy this application. It will give you another endpoint, but it will not be your main endpoint. So your traffic won't be routed to this. So yeah, it's a same service. Version ID is v2. Yeah. So this will deploy it. Let this happen. I could have done one more thing here. This also included your, the Git files. So I could have, removed. I could have ignored the Git folder from this. But let this happen. Upload is done. It's just starting up the service. Any questions are till now? And also, how is the speed? Like, is this fine? Should I go faster or should I go slower? Also, in terms of content, is this simple enough or is it going over your head? If anyone can give me a quick feedback. Speed is good. Okay, right. So yeah, this is done. It's deployed, and you can see that the the URL here states v2-dot-dsc, and it's not the default one because I put in no promote. So if I open this on my Google, the cloud console, it will show me 2 versions here, but the traffic is still being served from the first one because I mentioned that the new one should not serve any traffic. So right now, this is the first one is the one that is serving traffic. For the second one, it will give me a different endpoint to use it. The main service will not serve this. So the application is hosted. This is the application. To let's say have incremental rollouts. So what we do is we split the traffic. So I'll just click on split traffic, and I can specify if this should be by IP addresses, by cookie, or by or to have this as random. You can look up these things on your free time to understand what is what and which one you can use. So yeah, this is the one that is serving 100% traffic. I'll add a new version. V2, let's say I will start with 10% traffic or 20% traffic. So now 20% of the requests will go to this, and 80% will go to the other one. So to demonstrate this, let me put this as 50%, so that when people visit this endpoint, they can see different versions. This is 50. Yeah. So this will update your service, and your traffic is divided between these two versions now. Yeah, it is done. So you can see 50%, 50%. Instances. Let's see how many we have. We have one instance for that and one instance for this. So if I visit this endpoint, see now I'm served. I'm being served the first one. So if I refresh it, it's random. It's actually random. So a few times you would get one application, a few times you get the application or the other application. So this is useful when, let's say, you're having a new feature come out, but you want to make sure people are receiving it well. So you can just start with 10% of traffic allocation, and then based on the feedback from those 10 people, you can roll out more. And let's say you've actually deployed something, but things are going very bad, and you don't have to edit any code here. You don't have to change any source deployment. You can just come here and migrate the traffic back to the previous version. And all of these things happen in real time. There is no downtime at all. So if you're getting like continuous requests, none of those things would be stopped. So that's the other advantage. Yeah, this is one thing that I wanted to demonstrate to you folks. I think that should be enough for the App Engine side of things. Let's Dockerize our application, and we will deploy this through Cloud Run. So Cloud Run is a service that will just deploy containers. It will do nothing else. So you will have to have an image. You'll have to provide Cloud Run with an image, and Cloud Run will deploy that as a container, and it will scale that. So you can specify, let's say, how many requests should come in. So if it exceeds so many requests, a new container will spin up. And we can also mention the maximum containers, instances that this can scale up to, and the minimum one. Since by default it is 0, so it will scale down to 0 when there is no traffic to save cost. But you can put a minimum number of instances there. So there's something called as cold start. So if you have no instances running because there was no traffic, and the next request that comes in, it might take some time to be served because a new container has to be spun up. This normally happens within a second, but if your application is using multiple dependencies and a lot of things need to be installed, in such cases it might take some time. So that is in terms of the containers itself. I'll just quickly show you what the Cloud Run is. So for Cloud Run, we will be using Google Cloud's container repository itself. Let's not use Docker Hub. So we will create a Docker file in the same directory here. We will create an image from here. We will run this image as a container locally. We will then push this image to our Google Cloud's container registry, and then we will use Cloud Run to have containers of these things. So let's do that. Let me close all the tabs that I don't need. Yeah, for this, you would need Docker to be installed on your computers. So for the next step, when you go towards CI/CD, you don't necessarily need Docker installed on your local computer, because we'll be building this using Cloud Build. But for this state, to demonstrate these things, I'll be using Docker to actually create my image and spin up the containers. So in the same directory, right? Yeah, in this directory, I'll have to create a file called Docker file, and this has to be named as Docker file itself. And let's put in a simple configuration for this. I will show you what I'm using as well. Just one moment. So this is the image that I will use as the base image. So as I've told you, Flask is a micro server. You will have to run it behind another production server so that it serves files. Well, I mean, it serves well the request. In the previous case, we were counting on App Engine to do it for us. Right now, since it's an image and we are actually defining everything, the whole environment, we will have to set up the reverse proxy as well. So in this case, you could use Gunicon as well. I right now I will be using Nginx as the server, and this is one base image that I found, and this is used quite well as well. So you can read the description. This is a Docker image with UWSGI and Nginx for Flask web applications in Python 3. Yeah. So I can use this image. So basically, what this image has done is that it started from some base image. It might be Ubuntu or something. They've installed Nginx. They've set up Nginx, and they've created an image out of that. So I will use this as the base image, and I will do my changes on top of this image. So you can also see like what you should do and where things should be. So the only requirement for this image is that they have already created a folder in your root folder called /app. Your application file should be within that /app. Because in the Nginx configuration, they've configured it in such a way that whenever a request comes in, your Nginx will search for a file within the app folder, and it will serve that. So this is the configuration of Nginx, and this is how they have set it up in the base image. I will use this base image, and I will set up my application. So I have done that. Let me just copy that to this, and I'll explain what I'm doing. So yeah. This is nothing fancy here. It's quite very simple. I'm using the from to start from a base image. This is the base image, and I also showed you which this is. Let me also give you these links on chat so that you can look this up. This is the base image that I am using. Yeah. So I use this base image. Then I'm doing a copy dot to /app. As I've mentioned, the requirement of that image was that our files, our Flask application file, should be within the app folder in the container. So I'm copying everything from this my working directory to the app folder of the container. So that is what this copy command would do. In the previous sample that I'd showed, I'd shown you that we were moving the requirements file first, installing them, and then copying all of the other files. I'm not doing any of those things here. It's quite simple. After copying all of my files to the container, I'm running pip install the requirements file. So everything that's within the requirements.txt file will be installed within the container environment. Then I'm setting some environment variables here. So yeah, so what this basically does is that your Python application will not serve the static files. You can also do that, but it's not recommended because your Nginx itself will serve. Setting environment variables. This is also the requirement from the image that I use here, the Nginx image. If you set this up, all the static path that you visit will directly be served by Nginx itself, not by your Python file, and it will serve it from this path. So this is the same path that I will have my static folder in. So when I copy my files, the static folder will go inside app. So any doubts till now? This is a very simple Docker file that I have written. Also, like if it's a bit advanced, please let me know. I can simplify things even further. But in that process, we might miss out a couple of concepts. But yeah, it's actually better to know the basics more than like having everything go over our heads. So yeah, this is the simple Docker file. So yeah, I have this as well. So I'll give you a link to this so that if you're doing this with me, you can just use the same thing. So yeah. This is the file. It's quite simple if you want to copy it. So once you have this in your folder, let's use Docker. So first thing that I would do is I will create an image out of this. So when I create an image, let me take this time to explain what happens as well. So it will search for this image. It will search for this image, and this is hosted by this person. So this is his user ID, and this is the image that he's hosted. If it's a global image, you will not have the slash here. If it's something like Ubuntu or Docker, I'm sorry, Nginx or let's say Python or something, you just have to write those. So it'll search for your images itself that on your computer. If you already have that image, it will just take that image. If it is not there, it will have to pull this from Docker Hub, which it will do. So to check what all images you have, you can just run Docker images. It will show you all the images that your host contains. And yeah, to check what containers you have, you can just run Docker PS. It will show you all the containers running on your computer. Let me just delete this. Yeah, now I don't have any containers running. It's quite fresh. So let me create an image out of this Docker file. To do that, I will just have to run Docker build. I can provide a name to it. This is a way you provide a tag. You can write a name and a tag with it. So let me just run this as DSC NIE. And dot is the path where you have this Docker file. Let me just check if I have this here. We do have this. Let me just check what the issue is. Just give me one moment. That is running. Okay, I have a my file name is wrong. I've named it wrong, so I missed the R here. It's Docker file. Yeah, you have to name your files as a Docker file itself. There's no other way of doing it. Yeah. So now it's building the image. So if for me it did not take much time because I already had this image on my system. This image. If you run it, if you don't have it in your system, it'll first download that image. So that might take time to happen. So if I check my images now, I will have this Docker image. Is the side. So yeah. So this is the image that we have. It's created with the size of about GB. And I've named it as DSC NIE G Club. So this is the image name. Now to check if things are running, let's just spin up a container. So I can do that by using Docker run. I'll have to provide the image name, which is DSC-NIE-cloud. And I can also provide a name for this container. I do that by writing --name. Let me write this as test1. All right, sorry. Okay, I'll just give a small explanation here. So -d would mean that it is detached. So you won't be in the terminal of the container. It'll run in the background. And -it would just have a buffer for the container so that you'll have a terminal to attach that to. So after I create this, I can attach this terminal to the terminal of the container. So I can run commands within the container. So yeah, it started the container. Now if I do docker ps, so this is the container running. So to check this out, I will not be able to access this container because the networking of Docker is different from your host system. So the Docker itself will have a different network, VPC, and this container will have a different IP address. So I will have to map a port of my host system to this port, the port of the container. So I will quickly stop this here. Docker stop. That's one. Docker rm test1. Yeah, in order to map your ports, your host system port and your Docker port, you use -p and you just specify which port to which port. So let me map my 8080 port of my computer to port 80 of the container. So in the container, your engine runs on port 80 itself. So yeah, it started. So now I will be able to access this application if I visit localhost and put the port as 8080. So you're able to access your container from your web browser because we mapped our port. So yeah, let me just stop this. I also removed the container. So all we have now is an image. So let's host this image on Google Cloud through Cloud Run. To do that, I will have to push this image to my cloud repository, the container repository. To do that, I will have to tag this with the host name. So if you quickly check how to do that, I just want to show you where you can find the host names. So this shows you how you can pull and push an image to the container registry. Yeah, if you're doing it for the first time, you'll have to run gcloud authentication for this command. So what this will do is when you run docker push, it'll use the Google Cloud's authentication to authenticate and push the image to Google. So like everybody else cannot do this, right? Only you should have access to push it to your container registry, and that's what we're doing here. So yeah, these are the host names that we have. So if you want to host, like put it globally, I mean, in the United States, you use gci.io. This is the host name. If you want to do it in US specifically, it's this. If it's Europe, it's this. If it's Asia, it's this. So this is, I mean, internally, all your images are stored as objects in cloud storage. So in cloud storage, you have different types of classes. So it might be like multi-region storage, it might be regional storage in a particular region. So let's use Asia, and your total endpoint would be your host name / project ID / image name, any image name that you can put in. So I will quickly tag this. You'll have to provide your host image. Yes. So the host image that I created was DSC NIE Gcloud. So this is the host image. I will tag this to my Google Clouds registry, which is asia.gcr.io / my project ID. Let me just quickly verify if my ID. So my project ID is DSC NIE Gcloud. It's the same as this. So it doesn't have to be the same. I've just named it the same. So I've put in the region host name or the project ID and this new Docker image, right? I can provide a name here. So I'll provide the same thing here. Again, it doesn't have to be the same. Just for simplicity, I'm just putting in the same name. So yeah, so I'm tagging my image with another name here, which is asia.gcr.io, which is an endpoint. Then you have the project ID, and we have our the image name. I put a wrong thing here. I've put DSC itself instead of Gcloud by mistake, but we will use the same thing. So next, what I would want to do is I will have to push this image to my container repository. I can just do that with Docker push this. So this is pushing this image to my container repository now. So after this is done, if I visit my container repository, I'll be able to see this image there. So with this, I can use this thing, my Cloud Run to spin up containers of this. So it is done. So now if I quickly visit my container repository here, tools. Yeah, my container registry will show you the image. So you can see there's an App Engine 1. So this is the image that App Engine created for you when you didn't do this, when you didn't have to define all of your Dockerfile and all of these things. App Engine did all of that for you. So this is the one that I created. So you can see that this is the latest one. If I deploy newer ones with the same name, you'll have multiple images here, and the latest one will have the latest tag. We can also put in different tags here. So I'll just open this up, and let's deploy this. You'll have a couple of options here. You can deploy it with Cloud Run. You can deploy it with the compute engine, which is a virtual machine here, and you can put it inside a Kubernetes engine. So Kubernetes is a bit more advanced. So it's a system where you can orchestrate your containers. You can specify which containers should run where, how networking happens within these, how you scale them, and also managing your containers. So it's a framework to do that. To do that, you'll have to create cluster of nodes and set up pods and things. It's out of the scope of this discussion, but it's a very good thing to understand and learn. So I will use Cloud Run to do it. So this opened up Cloud Run, and you also have two options here, which is Cloud Run, which is fully managed, and you have Anthos. Anthos is something that Google Cloud provides for hybrid cloud. When you have your own data center and you have Google Cloud and you want to manage resources in both places, Anthos is something that helps you do that. So service name, again, it's a service here. Let me name this something else. So I will name this as staging. I will tell you why I'm doing this later. So you have something called as unauthenticated invocations and require authentication. So if you put in require authentication, you'll have to generate an API key here, and only people who have this API key can access this. Everybody else will get unauthorized error. So yeah. So if you're building something and you have to provide, let's say, authentication to the service, you can generate an API key in IAM, and you can share the same with your customers. And with that, you'll be able to track who all visited how many times and stuff like those. So yeah, I named this staging and region. I'll put the region as Singapore. The reason being Mumbai is at capacity now, so I'm not sure if we will be able to deploy this in Mumbai. So I'm just putting this as Singapore. This is the image, advanced settings. So by default, your Cloud Run expects that your container has a service running on port 8080. So for us, that is not the case, right? We're running Nginx and it's running on port 80. So I can just specify port 80 here. And then you have a couple of other options. Here you can specify how many CPU should be allocated for this container, what's your memory that has to be allocated, and request timeout. After how many seconds should the request timeout. Also, you have the auto scaling feature here. So the minimum number of instances and maximum number of instances. So within this range, your Cloud Run will spin up instances. So let me do create. So this will create a service, and I mean, yeah. So yeah, this is currently creating a service, and in a service will have multiple revisions. In the meantime, let me do something else to save time. So let me commit the changes that I've done here, and I'll put this to GitHub. So you might see the different icons there. It's something that I've set up. So you can do that as well. So it in your terminal itself, it helps you understanding what the status is. So yeah, I have pushed this also, and my staging service is ready in Cloud Run. So if I open the URL, I should be able to see this. It says bad gateway. If I refresh again, it should give me, yeah. So the first time when it showed you bad gateway, it just meant that your container was not up. You did not have a container instance there, and the second time it spun up a container. So we have this ready here. Next, yeah. So let me just summarize what all we've done before moving to the next part. So in the initial half an hour, we understood some the basics of virtual machines, the Docker containerization, and then when we started deploying, we deployed our application to Docker. I'm sorry, the Google App Engine. We looked at how we can have multiple versions there, how we can split traffic there, and then we Dockerized our application. We built the image locally. We pushed that to our container registry on Google Cloud, and then we use Cloud Run to run a container of that image. So we've done so much. Now let's add some CI/CD workflows into it to automate the whole stuff. So let's do it in such a way that all I would have to do is push my changes to GitHub, and my cloud build in Google Cloud should pick up those changes from there, build the Docker image, and upload that Docker image to my container registry, and have Cloud Run spin up a container of that image. So we will do all of that right here. So let me just click on setup continuous development here. So I don't need that. It's just listing my repositories. Uh, what's the name? It's Flask app repository. Let me open that up also. I can show it to you. So yeah, this is the application. I push my changes. We have our Docker file and the rest of the files here. And we are on the branch which is main. So yeah, I understand advanced options. Don't need them. Cloud build, right? So you have two options on cloud build. You can either provide a Docker file and cloud will pick up that file and create an image, or you can provide another configuration to cloud build. So in that configuration, you can actually write steps, and your cloud build will process those steps. So if you want to do something like unit testing or something that some other tests that you want to run, you can do it through that. So let the branch that I use is main. I'm using the main branch, and the type I put this as Docker, and the file is also here in the Docker file. So I'll click on save. So this will set up. So what will internally happen right now is this will actually start the process now because I just set it up. So this will call the build. So cloud build will process this. So if I go to cloud build, so this is cloud build. So cloud build will be listening to changes in your GitHub. So whenever let's say a merge happens or you push your changes to that branch, cloud build will pick it up. It'll take that Docker file. It'll create an image. So the same thing what happened on my computer happened here. So it's starting from this base image. It's pulling that image because it does not have that locally. Which is done, and yeah, it'll process all of these things. It'll create an image. It'll push that image to my container repository, and then it'll use Cloud Run to create a container of this. So deploy is happening. Right now, it's the Cloud Run is pulling this image. Let's just wait for that. Okay. In the meantime, let me do something else. So you might also have questions like, so if I'm deploying to production, I might have to provide credentials, right? If I'm using a service, something like a database or some other third-party service where I have to consume service, I'll have to provide my credentials. So if it's something like a mail server, SMTP server, I'll have to put in my credentials. If it's something like SQL or something else, I will have to provide my credentials. So how do I do that if I'm pushing my code to GitHub? So I cannot publicly push this to GitHub, right? The solution is not having private repositories, but yeah, you do that through your environment variables. So in your code, you can specify that this variable is an environment variable, and you can use that. And while creating these containers, you can provide these environment variables. Let me just quickly demonstrate that to you. While this build is running, let me open up the same Flask application, main.py. I'll just create another root here. So what I would do is let me put this as testing. Testing. So what I will return is, let me return something like this. I will have to import the OS module. So yeah, return hello plus yeah. So what this will do is, if I've set a variable called name in my environment variable, it will fetch that. So that will be substituted here. If not, it will just use stranger as this. So when I visit this, if I have not set an environment variable, it should show hello stranger. If I've set an environment variable named name, then whatever the value I've set, that should come up here. So this is the change that I have made here. I hope, yeah, the build is complete here. So if I go back to my cloud run, it should be, I will be able to see another, yeah, within the staging service, I will be able to see two revisions. Yeah, there are two revisions, and 100% of traffic is being served from this revision. So I can again, as I did with the app engine, I can also manage traffic. I can put certain percentage to one revision, certain percentage to another revision. What I can also do is that this container at the moment is not there. So there is no container for this. It's just the storage. It's just that I can create a revision URL. So if I write some create a URL here, another container will be able to spin up, and I can visit that with that URL. So this got deployed because I had a commit on GitHub. So if I push something else to GitHub again, another build process will run. So let me do that. But before I do that, I will do something else. I will provide an environment variable. So let me put this as name, and let me put this as Milan itself. Deploy. This deployment will happen very fast because there's no image being built, right? So it's the same image that is already there on the container registry. It's just I'm spinning up a new revision. So this happened. Now what I want to do is that I will push this code to GitHub. The only change that I've made is I've added a new function, a new path. And when I push this to GitHub, a build process should run and this should be deployed. So that will happen. So it's a single file that I've changed. So I pushed it to GitHub. Now, if I refresh this page, I should see a different status here. And also note that we will not, there won't be any downtime. So right now, this is serving 100% of the traffic. So this states that there's another build running. So I can visit the build history and check that. So there's another build running here because I pushed my code to GitHub. So with this system right now, all I have to do is, after I've set this up, all I have to do is I make my changes, I commit, and I push to GitHub. And all this build process of the system building a new Docker image, pushing it to the registry, and deploying this on Cloud Run will happen on its own. So that's the CI/CD workflow of Cloud Build. We have about 2 minutes left. So I can show one more thing to you, but it will probably take 10 more minutes. So yeah, I just want to ask you if you can provide me with 10 more minutes for that.
Yeah, Milan, take your time. We're learning and it's fine.
Yeah, all right then. So let this build happen. So what I want to talk to you about right now is the the environments that we have in the industry. So when you have your system itself, right? So you'll have like multiple different environments itself. So one might be staging, one might be testing, one might be acceptance, and the final one is your production environment. So when people deploy things, right, after they've built everything, first they deploy to staging. So staging will have not just on like cloud and let's say this application, it will have its own system, its own data. So your production data is never used for your testing or your building stuff. So if it's a business, if it's let's say a bank, you will not use customer data there. You'll use dummy data. So if you're using a let's say a MongoDB or any of the databases as well, right? You will fill it up with your dummy data, and that will be in your staging. So you'll build your applications in staging, and you'll deploy it. You'll test everything out. Once like everything is fine and you're confident that it can go to production, you do the same in production. So that is the reason I named this as staging. So what I will do right now is that I will create a new branch called prod. So that will be a production branch, and I'll create a service from Cloud Run to have my prod service be listening to the changes in prod. So I will make no changes to prod. I will do all of my changes to the main repository itself. And once everything is fine, I will create a pull request to my main. I'm sorry, my prod branch, and I will merge that. So once that happens, my prod instance will be deployed. So that is what we usually do. So well, I mean, in the simplest terms, that's how the version management and deployment and having different environments in development, staging, and production works. So I will quickly create that here itself. Okay. I hope you folks know how to use Git and different branching and stuff. So I just switched to the production branch. It's the same thing. I'll not really make much changes. I'll just push the same. Yeah, so prod is pushed to prod. So yeah, this is also deployed here. Let me go to Cloud Run. So it says staging is, the green tick mark shows that there's no other deployment running. This is already, that, I mean, all the builds are done. So this is serving 100% traffic now. This is the recent one that we have. And if I open this up, the second time will work. So there was no instances running at that time. The first time, it's a cold start. So this is the application. And I showed you two things, right? If there was no environment variable, if I go to what was that again? Was it testing or it was testing, however. It says hi, hello Milan, because I set up the environment variables. If I go to variables, I've set this variable. So this is just to demonstrate how you can use your environment variables within your application. So if you have something like a username and password, or if you have an API key that you have to use within your Flask application, and you don't want that to be present in your code on GitHub, this is how you do it. You just use the environment variables there, and while setting up your containers or your virtual machines, you put that as environment variable here. So this environment variable is not visible to anybody here. It's just with me, and this is how we did this process. And let me also demonstrate something else to you. So I think this application, the way it's built, if you go to /add card, you can add a new card. So when I do this, there are two things that can happen. So if the file system, the files that you have within your container, if they have like read-write permissions, only in that container this changes would be written to. And most of the times you don't have read-write permissions. It's just a read-only file. So you'll get an internal server error. And even if you do make that change within that container, if you spin up, let's say 5-6 containers, the remaining containers will not have this change. Because this is that's why you should not preferably have your applications as a stateful application. So stateless applications can scale very easily. So you can spin up as many containers as you want, and since they're stateless, they don't depend on your previous request, and they don't depend on your file system that changes to that file system. So let me just put this as testing. Learn. We'll submit this. So it says URL not found, because the card 6, right? The container that I might be using right now will probably not have this. So if I refresh this, I got this now, because this container might have it. So there might be instances where the Cloud Run might start and stop your containers at a very faster rate. So right now this container is showing me this data. If I refresh it again, I still have it. Yeah, now I don't have it. So it depends on the container. So which container is serving you data. And it turns out that Cloud Run does allow you to write to it, but since it's not stateless, only one container has this change, and that's the container that's actually serving this. So I demonstrated this to you. Let me just also show the other service. So let's have a production service now. So this production service is where I would actually have my production. So if I have my this thing, right? If I am pointing a custom domain, let's say something.com, milanmenezes.com. If I'm pointing that to something, I will point that to production, and that domain name would be pointing to this. So I can do that, but it will take a lot of time. That is presentable. So I'll create a new service. I'm just having the service as, or we just have this as prod. Blockchain. Next. Continuous deployments. Set up Cloudberry. Docker file and done. So this will spin up the process. This will have it will create a trigger on Cloud Build to listen to changes on GitHub. For okay, I think I screwed up. I don't think I put the branch right. I'll redo this. Edit. Yeah, the branch should be prod Docker file. Zip. Port should be 80. I'll provide the environment variable as well here, which is the name. Let me, any volunteers here, I'll pick name here. Let me take Pratyusha. Okay. So yeah, this will create a trigger on Cloud Build, and Cloud Build will be waiting for changes on the prod branch of GitHub. So whenever there's a change, this will spin up the process. So your Cloud Build will create a new Docker image from your Docker file. It'll push that image to your container repository, and it'll have Cloud Run deploy that image as a container, and traffic as well. It'll split the traffic and migrate the traffic to the new container. So the build is running. So yeah, that is how we basically do things. So if I, let's say, make a different, if all of my changes would be done in this main branch, right? This is the staging branch. So all of my changes would happen here. Once I'm very confident that this can go into production, I will merge this master branch to my prod branch. When that happens in my Google Cloud, build will pick that up and it will deploy the same. So that is how we do things. Yeah, this is it's just taking some time to do it. And I'll also quickly tell you how you can point your domains to this. Just an FYI, the Mumbai region does not support mapping your custom domains in Cloud Run. So you can just click on manage custom domains, add mapping. So yeah, you select which service you want. Of course I have to do the production itself, and then you select a domain that that is verified to your name. So I have a couple of these registered. This is a free domain. So if you're looking for a free domain, you can just search for free domain name, and you will find Freenom. Freenom is the one which kind of gives you free domain names and DNS to use those. You can like register a domain for free here, which ends with .tk.ml and stuff. Typically what happens is that when you get a domain name, you go to your DNS and you add a couple of entries. So if you want to point your domain name to an IP address, if let's say I have an IP address for this application, I create an alias ID. I create an A record, and I point that to this address. If it's something like a subdomain that I have from here, I create a C name, a canonical name record, and that will point to this. So this is what you typically do. But here in Google Cloud, you also have to verify that you own that domain. This is done in a couple of places. Even when you are using a third-party mailing provider, right? Either let's say Google Workspaces, G Suite, or Zoho, or any of these folks, you will have to verify that you own the domain. So to do that, you will create a text record, and you copy the string provided by let's say Google Cloud, and you paste it there, so that this text record is publicly available for folks to request from the domain name. Once you do that, it'll verify that you own the domain. Once that happens, you can map that to this. So let's say you select a domain name, it's already verified, and you updated the DNS records. Here in DNS, it will give you a couple of IP addresses, and in your DNS, you'll have to go update these as alias records. With that, it'll point it. I don't want to do this because it will take some more time here, and we've already gone over 10 minutes. Yeah, so that will basically do it. And the reason you have a couple of IP addresses here is because these IP addresses are of the Google front end. So your IP networking ends at Google front end. After that, all of the things at the back are through RPCs itself. So your request could be served by any of these IP addresses. That's the basic understanding. I hope. Yeah, the production is also done, and so we have a production setting. So this is the production URL. This thing, right? The domain name that we buy, either free or a paid one. You can point it to this. So this could be something like your name.com, your name.tech, or your name.co.n, something like that, and we'll point to this. And all your changes, you can have it on your staging, and you can create a subdomain to it. So let's say, let me take an example. What do we have here? We have Sagar. So let's say Sagar buys sagar.com domain name, and he'll point it to production. And all the changes that he makes is in staging. For staging, he can remember this URL, or you can just create a subdomain. You can have something like staging.sagar.com, and that will point to your staging service. And whenever he makes changes and pushes to GitHub, it'll be deployed to staging. So you can check how things are on staging. If he's comfortable seeing the same on his phone, on his laptop, and a couple of other devices. And if you have something like a notification service set up, some workers running on the background to check things, so you can test all of those things. Once you're comfortable with all of those things, then you can move to production. You can just merge your main branch to your prod branch, and then that will be deployed on its own. So that is how things are done. And that's about it from my end. So what else do I have here present? We went through App Engine, we went through Cloud Run, we went through Cloud Build, and how to contact me. If you have something where you have to reach out to me, if it's a doubt or any other thing that you want to reach out to me to, you can feel free to do so. So I might be busy, but I will respond back whenever I'm free. So these are my personal contact details and my corp details. So if it's something to do with a professional thing, if let's say you're looking to invite me to another event or any of that sort, you can use my corporate ones. Or if it's something of a personal sort, if you want to text me on WhatsApp, you can use my personal details. So yeah, that's about it. Also, I have my LinkedIn here if you want to have me on your connections. So thank you.
Thank you, Milan. That was really informative. I really enjoyed the session, and I know that most of the people who attend here already like you, because you taught complex topics in an easy and a simple way so we can understand it. That's what I like, because you boil down the complex essence of Google GCP as the app engines into a very easy and very human friendly way, or like a beginner friendly way. So I want to thank you for teaching us, and I want to thank all the participants for coming over and participating in this event. And of course, Milan, we'd love to have you in all the future events, and we hope to see you again and collaborate in the future also.
Yeah, I'm looking forward to that. And thank you for you folks for organizing this, and having this club as well, and guiding folks. So it's a great job, and folks are really enjoying this, and they can learn a lot from these events. Thank you for having me here as well.
No, that's
Also,
our
a huge
pleasure.
thanks to all the participants, because like not everybody is interested in all of these things, right? So most of the folks are more towards academics, and they don't really have many skills. They don't tend to build these things either. So cloud is one space where it's vast. You can pick up just one space and you can do a lot in these things, and it's good to know that at 21 folks are interested in this, and they've been with us till the end. So, and my apologies for extending this by 15 minutes.
No, 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 it's
So,
fine. It
yeah,
was all in the sake of learning, so it's for a good
yeah,
cause.
yeah. I
Uh,
actually, wanted this to be a full day workshop, so I could have done even more. But yeah, as we both know that we couldn't get a slot for that next
yeah.
week's the Sarah, and last week was the Dev Fest. So yeah, but you still figured out a day to do this and have me here. So thank you for all of that.
Thanks for taking time for your schedule
Yeah,
to come teach
no
us.
issues.
So if anyone has any doubts or anything to say at all, you can just speak up. It's fine. Or you can just drop it in the chat. No worries.
I want you to do one more thing. I want you to send the participants a feedback form and get their feedback.
Yeah,
So
yeah,
it
we will.
can just be a blank, text box where people can write what they feel about, and you share the results with me.
Yeah, Milan, we already have the plan, so we'll let it know. But I'm pretty sure that the feedback will be amazing. You taught really well, so I wouldn't doubt much.
Okay. Thank you for that.
Yeah. So, anyone has anything to say about any doubts about the event or anything about the event in general? You can just unmute yourself and speak if you want. I guess no one has anything to say. I think I already said everything that I wanted to say. So
And
yeah,
yeah,
I,
one more thing. I usually keep saying this in most of the sessions that I take. People kind of feel hesitant to reach out to folks. So I'm giving you an open invitation. If you have anything, you just ping me up. Tell that you're from NIE and you're looking for guidance on this or that and stuff. I might be busy. I might respond at the same time, but I will get back. So this is not just with me. A lot of the alumni are at the same status. So they are more than happy to help out and more than happy to clear your doubts or answer anything that you have doubts on. So yeah, feel free to reach out and don't be hesitant on anything.
yeah. And if you guys want his details again, and if you like, couldn't get it when he showed it to you, feel free to ask us, and we'll share the contact details
Yeah.
with you. Okay? No worries with that.
All
So yeah,
right.
yeah. Sorry.
Yeah, no, I just was winding this up. If you have anything to say, you can just go ahead.
Yeah, no, yeah, it's fine. You can say whatever you wanted. Yes,
All right then. Thank you for attending, and have a great day. Yeah.
yeah. Thanks, Milan, for
Cheers.
teaching us. And yeah, as usual, we'll always be active in Discord. So if any of you guys want to come talk to us, like get advice on any technical stuff, want some help, or just plain talk, feel free to just hop onto the server and we'll be there. So yeah, I think we can end this now. Stay safe, stay curious, and have fun. Thank you, Milan. Bye bye.
Cheers. Bye.